have you ever pondered how computers make decisions? It's quite a fascinating journey into the world of binary logic. This is the realm of logic gates, the basic building blocks of digital systems. Imagine a bustling city with various intersections, each controlled by a traffic signal. The signals decide whether vehicles should stop, go, or wait. Similarly, in the digital world, logic gates control the flow of information. Let's dive deeper into this world, starting with the most basic gate, the NOT gate. The NOT gate, as the name suggests, simply negates the input. If you feed it a T1, it will spit out a 0, and vice versa. It's like a rebellious teenager, constantly disagreeing with everything you say. Next up, we have the AND gate. This gate is the embodiment of the principle of teamwork. It requires both its inputs to be 1 in order to output a 1. If even one input is 0, the output will be zeros as well. It's a bit like a strict teacher who expects all students to be present before starting the lesson. Then there's the OR gate, a much more lenient entity. If any one of its inputs is 1, it will output a 1. Only when both inputs are 0 will it output a 0. It's like a party planner who only needs one person to show up to get the party started. The NAND gate is a combination of the NOT and AND gates. It behaves like an AND gate but negates the output. So if both inputs are 1, it will output a 0. Otherwise, it will output a 1. It's like a reverse psychology expert saying the opposite of what you expect. Similarly, the NOR gate combines the NOT and OR gates. It will output a 0 if any of its inputs is 1 and a 1, only when both inputs are 0. You could think of it as a grumpy old man who says no whenever he sees a crowd. The XOR, or exclusive OR gate, is a bit more selective. It will output a 1 only when its inputs are different. If both inputs are the same, it will output a 0. It's like a picky eater who only eats when the dishes are varied. Output. Finally, the XNOR, or exclusive NOR gate, is the opposite of the XOR gate. It will output a 1 when its inputs are the same and a 0 when they are different. It's like a person who finds comfort in routine and dislikes changes. To wrap it all up, logic gates are the traffic signals of the digital world. They control the flow of information based on their type. The NOT gate negates the input. The AND gate needs both inputs to be 1 to give a 1 output. The OR gate needs any one input to be 1 for a 1 output. The AND and NOR gates are like the NOT gate combined with and OR gates respectively, while XOR and XNOR gates look for difference and similarity in inputs respectively. These gates might appear simple, but when combined in various configurations, they form complex circuits capable of performing detailed tasks. They are the unsung heroes behind the seamless operation of our digital world, from the smartphones in our pockets to the supercomputers exploring the frontiers of science. So, next time you use a digital device, spare a thought for the humble logic gates working tirelessly behind the scenes.